right, so we need to remember how to reduce fractions. How do I reduce 15/6? Bobby. Perfect. What is the greatest common factor? 3. Very good. So I divide this by 3 and divide this by 3. So 15 divided by 3 is 5. 6 divided by 3 is 2. Now, I walked around and some of you converted that to 2.5. That's okay. But usually when you're reducing, you just reduce it and you don't have to change it to a mixed number unless digits tells you you have to. Okay, what's the greatest common factor in number 2? 3 works. There's a bigger one. Yeah, 6. But you can do 3 if you want. You just have to do it twice. All right, so divide by 6, divide by 6. So I get 3 over 2. And again, you can leave it 3 over 2. That's okay. Okay. You got that one. Awesome. All right, next one. 3/15. Emmy. So the greatest common factor is? 3. 3. There you go. 3. So I get 1/5. Okay, that's the scale we're going to be using today. All right, then multiplication of fractions. We're going to use this skill today too. Who remembers how to multiply fractions? Andrew. Yes, the bottom does not have to. You don't have to have a common denominator. Okay, and you can multiply straight across the top, straight across the bottom. Daniel?
I have a question.
Okay.
On number 3, what if you put 5 in that one?
If I have 1 out of 5 slices of pizza, is that different than having 5 whole pizzas?
Yes.
Yeah, those two are very different. Yeah. You do not, no, you do not do the reciprocal. That's when you're dividing. Good question. All right, there's a shortcut. If you don't want to have to just multiply straight across the top and straight across the bottom, who remembers the shortcut? My fancy people. Cross reduce. We're going to be using this today too. So I would say 3 goes into itself once, 3 goes into 9, 3, and now I would multiply straight across. So 2 times 3 is 6, 1 times 11 is 11. If you didn't do that, you would have gotten 18 over 33, which means you would have had to reduce it to 6/11. Either method is fine. I just like shortcuts. Okay, what about number 5? Are there some shortcuts there? Bobby?
5 and 15.
Yeah, 5 and 15 will cross cancel. So 5 goes into itself once, 5 goes into 15 3 times. Is there any more? Yeah, 4 and 16. So 4 goes into itself once, 4 goes into 16 4 times. Okay? Then I have a negative on there. So a negative times a positive is always a negative. Remember, we're multiplying 2 negatives, make a positive, 1 negative keeps it negative. Okay, so now we're going to multiply straight across the top. And I have a negative and then 3, so negative 3. And 1 times 4 is 4. So my final answer is negative 3/4. Okay, questions on any of those? We're going to use that today. All right, so learning goal for today is that you are going to be able to write and solve basic one-step equations. We're only going to work on the foundation today, and then we're going to continue to build up. Okay, during this topic, you're going to have a lot more paper homework versus digits. We'll still do both, but we're going to have more paper because the steps are so important to our foundation. Okay, and on digits, I just don't trust that they're going to give you enough problems, and I don't trust that you're going to be really good at writing them down. Okay, all right, so first of all, I want to give you a visual so that hopefully you understand what I'm talking about today. So this first one says 3 plus x equals 11. You should be able to do this mentally. My own children who are in grade school are doing ones like this mentally. This is saying 3 plus blank equals 11. What's the blank? 8, right? Okay, so good. Now, do you think every problem I give you this year you're going to be able to do mentally? No. Okay, so you're going to have to find a system. Okay, now I want you to see this thing's picture. This picture is of like an old balance. Okay, but I want you to think of a teeter-totter. Okay, do you guys know what teeter-totters are?
Yeah.
Yeah, they look like this, and you put kids on this side, kids on this side, and then they go up and down and up and down. So what happens? You call them a seesaw?
Yeah.
Okay, call them a seesaw. Okay, so what happens if I decide to put, let's see, Hunter, okay? I put Hunter on one side, and then I get my 6-year-old, who weighs about 30 pounds, which is tiny, and I put her on the other side. What's going to happen? Yeah, they're going to sit like this, and he's going to be like jumping off the ground, and she's just going to be hanging out up here in the air. So when you're on these seesaws, they always have to be the same weight on both sides. Does that make sense? Because if not, you can't balance have to think about with this. These two right here weigh exactly the same amount. Okay, that's why there's an equals here. So right now, you guys already told me that this equals 8, because 8, 9, 10, 11 makes this side 11. And this is 11 ones, so this side is 11. So those two are balanced. Okay, what happens if I say, I want to take these 3 away? What would I have to do?
You have to take 3 away from that side.
I'd have to take 3 away from the other side. Does that make sense? Or otherwise, they can't balance anymore. So then I take 3 away from this side. Okay? So if I do that, all I have left over here is a x. What do I have left over here? 8. So that x equals 8. And I just solved the equation. So what is that going to look like if we have to do it on paper? Because we don't want to have to build a picture like this every time and think about it. And not always are we going to be able to do it mentally. Okay, so here's what you're going to do. When I say that I care about the steps, here's what the steps look like. You're going to start off by drawing a line through your equal sign, because that's going to represent that you have 2 sides to this seesaw. Okay? And if you say, well, why do I have to do that? Well, eventually I'm going to put variables and numbers on both sides, and they're going to get really crowded, and it's going to help you see which side is which. Okay? Now, what did I do here? Here I took off 3. Does that make sense? So that I could have him by himself. Because letters and numbers don't like each other. They want to be on opposite sides of the seesaw. So think about them like enemies. Okay? So if I took off 3, how do I represent that with math? Take away 3. Minus 3, or subtract. So I'm going to subtract 3. Because what is 3 minus 3? 0. So now I have 0 and an x. But if I do it to one side, I have to do it to the other to keep them the same. And so what drops down here is the x. And I do 11 minus 3, which is 8. And that's how I show my steps. And that's how I do the algebra part. I should see that on every single one of your boards, because that's what I said you're going to have to show on your homework tonight to get credit. Is those exact steps. If you come in with your worksheet tomorrow without these steps, I'm not taking it. Because we're practicing getting that good foundation. And you have to trust me that this is going to get harder. All right, so let's look at some more. Okay, now this first one, I would think you can probably still do mentally. The first one says x minus 12 equals 3. So blank minus 12 is 3. What would be the blank? Not 9. 15. 15 minus 12 is positive 3. I know, because we got to think about positives and negatives too. Okay, so we're going to start by drawing our line. So we're going to draw our line through our equals. Okay, so I know the answer is 15. So how can I show that the answer is 15? Well, instead of subtracting 12, the opposite of subtracting 12 is adding 12. So let's see what happens here. If I add 12, what do I get when I put these two together? No, 0. Because it's negative 12 plus 12 is 0. But if I do that to one side, I have to do it to the other. So I need to add 12 here, add 12 here. So what drops down here? X. 3 plus 12 is 15. And isn't that what you already told me it should have been mentally? Because it should have been 15. Okay? All right, number 2, you should be able to do mentally. Blank plus 7 is 10. Should be 3. Okay? So what do you think I need to do to both sides so I can get 3? Subtract. So that's add 7. So I want to subtract 7. Or it's a positive 7, so I need to think negative 7. And I do that to both sides. So the y drops down. Positive 7 and negative 7 make 0. So I got rid of that. And 10 minus 7 is 3. All right, now can you do 3 mentally? The answer is not 12. The answer is negative 8. Okay. Now, that becomes harder to do mentally. Do you agree? Because some of you are still going, I don't even know how I got -8. Okay. It's not hard. Okay, what do I need to do, Nick?
You need to put a line through the equal sign.
Very good. Yes, Nick?
And you subtract.
Eh.
No, you add 2, don't you?
You do add 2, right? Because that's what I've taught you to do every time. So you add 2, add 2, add 2. And so what drops down here is the B. And then now you have to think of your positives and negatives. Because remember I said those were never going away. So we have a -10. So this is I owe you $10, but I have 2 in my pocket. So what's my balance? Not positive because I still owe it to you, right? It's -8. Okay, now some of you who are really good at positives and negatives, you could do that mentally. Some of you need a process at this point. Okay? All right, are we good on those before we go to the next slide? Okay. All right, so let's get a little harder. So look at that first one. Can you do that one mentally?
No.
Okay, some of you probably can. Some of you are saying, yeah, I can't. I don't know what that is. That's why I need a system. Do you know what to do based on what I just taught you? What do you think? What do you think? Andrew? Good. Exactly. So because I've taught you a system, you're like, oh, instead of, because it was -0.7, I need to add 0.7 to both sides and bring down the B. Okay, and so now if I needed to pick up my calculator at this point, I could. But it's basically like saying $2.40 plus 70 cents. How much would that be? $3.10. So 3.1. Okay. All right. The next one. Can you do that one mentally? Some of you can? No, some of us I can't. But I taught you a system. So what's the system? What am I supposed to do here? Layla.
Do the line down the equal sign and then do the opposite of the subtraction, which would be the plus 1.2, and then the other side do the add 1.2.
Perfect. Yep. And so now I need to think, I owe you like $3.30. I only have $1.20 in my pocket. Brandon? What? 2.1. Do I still owe it to you? So I would make it -2.1 because I'm really just subtracting those two. You have to remember your rules for positives and negatives. Okay, now if you could do number 9 mentally, you are impressive. Can you do number 9 mentally? Andrew? No, I said mentally. Can you do it mentally? Oh, then you're saying in your brain this is what I would do? Okay. So I'm saying, can you do it just by looking at it?
Oh no.
Oh, no. Okay. So, but again, we have a system, right? And the system helps us when we can't do it mentally. Okay. So just like he said, I would draw a line through here. And what would I do to both sides? I would discourage you from flipping it around because as they get bigger, you're not going to want to waste time rewriting them. It will annoy you. No, because these would be non-terminating decimals. That would be a mess. I don't want to do that. What's the system I taught you? Emmy?
Well, no, not for that.
How would I get rid of 1/3? Okay, don't think of this as any different than anything else I've taught you. What would you do if it was this? How would you get rid of the 3? So how do you get rid of the 1/3?
-3.
Negative, no. -1/3. I heard somebody say it. -1/3. Yeah, it's the same system, no matter what the number is. So you're going to -1/3. -1/3. Because what is 1/3 -1/3? 0, right? 1/3 -1/3 is 0. So what do I have left over here? A V, right? We haven't done the hard stuff. This is the easy part. Okay, now the harder part is I have -5/6 and -1/3. So how do I combine those two together? They're both negative, so what operation am I going to be using? Because I owe you and I owe you. I want to add them together. What do I have to remember?